the same, the introduction of metal finishing and its technological importance. Then what is electroplating? Introduction of that, then principles governing electroplating. Under that we have polarization, decomposition potential and overvoltage. Similarly, we are going to discuss about electroplating of chromium, electroless plating and plating of nickel, copper and distinction between electroplating and electroless plating in the next session in the part 2. Now let us see what is metal finishing. So we can define as a process of electro deposition of adherent metallic film of uniform thickness on the surface of the substrate for the purpose of modifying its surface properties. For example, consider metal iron, and we are modifying the surface of iron by covering a very thin film of gold on the surface. The film developed must be uniform thickness on the surface. Now here metal iron is the substrate and gold which gives the property. The surface property is varied because of the presence of gold on the surface of metal iron. Dear students, as you all know, the appearance matters. So the look of the material really matters while we are utilizing different tools. It may be made of a plastic or it may be metal. Now here in this picture you can see different types of objects or materials which are made of metals, and it looks so shining and brighter and it looks so elegant or majestic because of the process of metal finishing. Here each and every particle or article present here is subjected to metal finishing. So the look itself makes the difference. So at present the cost and the maintenance, everything depends upon the surface finishing, that is metal finishing. So nowadays metal finished articles we can find everywhere in every shop, and that's what we have the latest car or the vehicles or many more things which are made up of metals. It may be the metallic alloy wheel, or it may be the door frame, or any metallic object that it may be a small keychain, or it may be the logo of car or anything. It is subjected to metal finishing so as to give a better look and long lasting appearance. In our daily life we use various metallic materials such as car components, window frames, utensils, washing machines, electrical appliances, building materials, jewelry, automobile parts and many more. While using such things we need corrosion resistance, wear and tear resistance, mechanical properties, electrical and thermal properties, ease of fabrication, etc. But no single metal can fulfill all these ideal properties. Therefore, metal finishing is one of the methods employed for the purpose of improving their lacking properties. Now, what is the objective of metal finishing in general? Dear students, metal or alloy used for a purpose does not meet all the requirements. Metal may undergo corrosion and it may not have the shining properties, it may not have the durability, or the alloy that we are using may not show the required conductance, etc. Once it does not meet our requirements, then we need to go for the surface modification. So metal finishing is one of the methods employed to improve these lacking properties. Now let us see what is the technological importance of metal finishing. Improving resistance to corrosion. This is very important thing. Why? Because metals undergoes corrosion due to the attack of environmental constituents. This corrosion theory and the reactions we have seen in the previous session in detail. The scratch or abrasion and wear resistance. So we need to improve these qualities on the metal. Therefore, this is the most important. enhancing decorative appearance, improving solderability and electrical properties. Some metal may not have good conductance. In that case, we can have a layer of another metal which is superior conductor, reducing frictional loss, imparting thermal resistance, imparting hardness, etc. Metal finishing was introduced as a decorative finish, but the increasing demand for parts with prescribed specifications has led to vast technological developments in the field. When you go back few years, we were using metal finishing in order to give the look for that surface. Now it is not only the look that matters, we need some more technological developments. We require the technological fulfillment from that layer so as to use for the purpose. When it comes to metal finishing, mainly we have two important techniques. One is electroplating of metals and alloys, that is electroplating technique, and the other one is electroless plating of metals and alloys. Dear students, electroplating of metals and alloys. Now the electroplating, the word itself indicates the plating of metal by using electricity. So by supplying direct current, you are going to deposit a layer of metal on the surface of metals or alloy, that is electroplating. And the other technique is electroless plating. Now here, without the aid of DC current, without using electricity, we are carrying out this process, hence it is called electroless plating. So here also we can use metals or alloys, or of course the plastics. On the surface of a plastic, on the surface of a metal or alloy, we can have a layer of metal, hence the process, of course, electroless plating. Now let us see what is electroplating technique. As I said earlier, direct current is used during this process. The process by which coating of metal is deposited on the base metal by passing direct current through an electrolytic solution containing the soluble salt of the coating metal. So common metals used are copper, nickel, zinc, gold, platinum, etc. used in industries for producing metal coatings. Now let us say we have the base metal iron that is subject to electroplating technique. Then we need a metallic salt solution. Let us say copper we have as an electrolyte, copper sulfate. It contains copper 2 plus and SO4 2 minus. The metallic component is copper 2 plus. So using anode and cathode component, we are supplying the current, direct current, through this electrolytic solution. Now let us say cathode is iron rod and copper 2 plus from the solution adhered on the surface of iron. As a result, copper is undergoing reduction and it deposited on the surface of iron, and this process is carried out in the presence of direct current. Hence this process is electroplating of copper on the surface of iron. The cathode reactions and anode reactions let us see later. Now just understand that this copper, nickel, zinc, gold or platinum solutions are acting as electrolytic solutions. They are kept inside the tank. And we have the object, for example metal iron. There we are having the coating of these metals. Now base metal, if it is iron, it acts as a cathode where reduction takes place. These metal ions are undergoing reduction on the surface of base metal, and a coating of these respective metal is formed on the surface. Here in this picture you can see this is the object to be plated. Let us say this is metallic key. It is, let us say, it's made up of iron. So this is connected to the negative terminal, it acts as a cathode, and here we have the copper sulfate solution, and this is the anode. Let us say it is the impure copper rod. It's connected to the positive terminal of the battery. So when we supply DC current, copper 2 plus migrates from the solution and it gets deposited on the surface of this key. Copper 2 plus 2 electron to give copper deposited on the surface of key, and this is the impure copper which dissolves into the solution. So copper 2 plus ions coming to the solution, and same amount of copper 2 plus is deposited on the surface of this metallic key. So as a result, this iron metallic key is converted into copper plated key. So this is what the electroplating technique is. Now here we use electrolyte, then anode, then cathode, then the direct current. So here electrolysis of this electrolyte takes place by supplying direct current DC. Therefore this is electroplating technique. Now here we have the electrolytic bath of copper sulfate solution. It contains copper 2 plus ions and SO4 2 minus ions, copper sulfate salt. And here we have the copper plate. It is connected to the positive terminal of the battery. It acts as anode. And here we have iron plate. It is connected to the negative terminal of the battery and it is acting as cathode. Now this iron plate is called the substrate. Now here what we are expecting, the deposition of copper 2 plus. So this copper 2 plus being positively charged migrates towards the cathode and it receives 2 electrons and it is deposited in the form of copper metal. So this copper metal deposition takes place on the surface of cathode. Copper 2 plus ions plus 2 electrons, 2E minus, it gives copper metal. So deposition on the surface of this cathode. Now this copper plate acting as anode. Now here copper metal dissolves or it undergoes oxidation to give copper 2 plus ions plus 2 electrons. See, the electron is moving like this and copper 2 plus ions are added to this copper sulfate solution. That is how the electrical neutrality is maintained. The copper 2 plus that is gets deposited on the surface here is equal to that copper 2 plus ions formed due to the oxidation of this copper plate. Now here this copper plate builds up, this iron plate builds up because of the deposition of copper, and this copper plate withers because it undergoes complete oxidation, and copper plate, pure copper ions plus electrons are produced because of the oxidation process of this. So here we have oxidation and here we have reduction. So redox reaction taking place because of the supply of direct current. Hence it is the illustration of electroplating process of copper using copper sulfate electrolyte. Now we know what is electroplating and how actually it takes place because of the oxidation and the reduction reactions respectively at anode as well as cathode. We have seen that oxidation with respect to anode electrode and reduction with respect to cathode electrode. So we have seen the illustration as well. Now let us see, before going to the actual electroplating technique, let us see what are the factors governing electroplating technique. Now here there are three important factors that governing electroplating technique. One is the decomposition potential, polarization and overvoltage. Now let us see in detail what is this decomposition potential and polarization and overvoltage means. We said, electroplating is nothing but a deposition of one metal on the surface of another. Generally we call it as substrate. by supplying direct current. Now here, direct current plays very important role. The process takes place with the help of direct current. So electrolysis because of the supply of direct current. Electrolysis means a splitting of an electrolyte. For example, copper sulfate. It is an electrolyte. It splits to give copper 2 plus and SO4 2 minus ions. So when this electrolysis or splitting takes place with the help of electrodes, copper 2 plus moves towards the negative electrode and negative ion moves towards the positive electrode. That is what the splitting means. So decomposition potential ED is nothing but the minimum voltage supplied for the continuous electrolysis of an electrolyte in an electrolytic cell. So if we consider a beaker containing sodium chloride solution. So sodium chloride solution Na plus and Cl minus ions. Now let us say we are expecting that Na plus ions to move towards the cathode and Cl minus ions move towards the anode. Now this movement is characterized by the supply of potential. So we need to supply minimum voltage. So what is that minimum voltage required for that decomposition? That minimum voltage required is called decomposition potential. Let us consider electrolysis of water. You know, water is H2O. It undergoes self-ionization to give H plus ions and OH minus ions. So this H plus ion and OH minus ions, one is positively charged and OH minus is negatively charged. Now, to this beaker, if we dip a pair of platinum electrode and if we supply some voltage, then electrolysis of water takes place. You can expect a liberation of hydrogen gas and oxygen gas at respective electrodes. Now it has been found experimentally that you need to supply 1.7 volt in order to carry out this evolution of hydrogen gas and oxygen gas from water. So this 1.7 volt required for the continuous electrolysis of water in the presence of platinum electrode is called decomposition potential of water in presence of platinum electrode. Remember, this decomposition potential depends upon the electrolyte. It depends upon the electrodes used, that is anode and cathode. So what is the nature of electrode and what is the nature of electrolyte? So both plays very important role during this decomposition. So decomposition means splitting, positive and negative, and they are migrated towards the respective electrode. So that potential required is called decomposition potential. So here we have mentioned 1.7. This is for the electrolysis of water. Remember, in the presence of platinum electrode. Now coming to over voltage. We said the decomposition potential is nothing but the minimum voltage that is required. Minimum voltage. Dear students, I might have given so many explanations during our regular lecture. I might have given enough examples to explain different concepts of theory. Now let us say tomorrow you are going to write the examination for 20 marks. It has 5 questions. See, theoretically, if you study that 5 full questions thoroughly, then you can answer all the questions and you will get 20 marks. Is it happening? Now, in order to study that 5 question answers, let us say for one question you require 10 minutes and you require 15 minutes to complete that 5 questions and answer. 15 minutes. Now, let us say 50 minutes or 1 hour is sufficient. That is the theoretical one. Theoretically, if you study all that 5 questions completely, you will get 20 marks. By studying all these questions and answers thoroughly, once, twice, thrice, you can attend the examination and you will get 20 marks. That is the theoretical concept. Teacher may say that if you study this one, you'll get full marks. But is it really happening? So what really going to reflect in the form of marks tomorrow after the examinations? Is it 20 marks or 19 or 18 or less than that? See, whatever we said here theoretically does not match there. It may be less than 20. Though you have studied properly, you are getting 50 marks, 15 marks, or some are getting 10 marks, some are getting 5 marks. See, some may think that 1 hour is sufficient to study those question answers, and some may think that 2 hours required, depending upon their, remembering capacity. So there is one theoretical aspect. So teacher will teach and students will study, but that theoretical answer or the reason does not coincide with your practical one. The practical approach is totally different. Most of the students may not get 20 marks. So there is a difference between theoretical and practical. I want to recall I've explained about time taken or time required to travel between two places. For example, from Mangalore to Udupi. Let us say theoretically, when the road is proper and you have got a good condition vehicle, then you can reach in 1 hour. That is the theoretical one. So even the Google map says you can reach in 1 hour. If you start now, within next 10 minutes, 60 minutes, you will be there in Udupi. Is it really happening? There are so many difficulties while moving. When we are doing the practicals, there are so many difficulties. One may take 70 minutes, other one may take 18 minutes. So it does not match actually with the theoretical one. So theoretical one does not match with practical one. So there is a difference. So this difference also observed even in electroplating technique during electrolysis. The decomposition potential of an electrolyte is expected to start as soon as applied potential reaches the value of reversible EMF of the cell. So by supplying the theoretical voltage, we expect decomposition, but that is not happening. In most of the cases, that practical voltage required is much more than the theoretical value. Always, in most of the cases. Generally, when the product discharged and the electrodes are gases, then actual decomposition potential is invariably much higher than its theoretical value. So this excess voltage that required for the smooth decomposition, continuous decomposition, is called overvoltage. This overvoltage may arise because of so many reasons. It may depend upon the type of electrode you are using and the electrolyte and the continuity, the current density, and all the factors that decides this excess voltage that is required. What we call it as overvoltage. Now this overvoltage is also not same for all the electrolytes or all the electrolytic process. It is different from one to the other one. So overvoltage is the difference between the actual applied voltage EMF to bring about continuous electrolysis and the theoretical EMF needed for such electrolytes. So actual one, that is called practical one, and the theoretical one. So theoretical voltage and actual, that is experiment. So there is always a difference between these two. So that is called overvoltage. Now let us consider, just now we explained electrolysis of water using 2 platinum electrodes. We said 1.7 volt. That is the actual voltage required. 1.7 volt. Exactly 1.6 volt. For example, a beaker containing water, to that 2 platinum electrodes are dipped. One is connected to positive, other one is negative terminal of the battery. See, we said 1.68 volt of DC current is required for the smooth electrolytic process, decomposition process. But here, the theoretical voltage is 1.23. Theoretically, if we calculate, then the required potential is 1.23. but the actual gas evolution takes place at a potential of 1.68 volt. The excess 0.45 volt is the over voltage for oxygen on smooth platinum surface. Actual voltage required is 1.7 volt. That is called the practical one, and the theoretical one is 1.23 volt. It doesn't match 1.23 and 1.68. Practical difference. So difference here is 0.45 volt. So this much excess voltage is required in order to have the decomposition of water using two platinum electrodes. So this excess voltage is called over voltage for the electrolysis of water using platinum electrodes. So factors affecting over voltage: electrode surface. See, the electrode surface may be very rough, or it may be very smooth, or it may be in the form of a needle, and it may have smaller surface area, or it may be a flat or larger surface area. The nature of the electrolyte: one electrolyte may be the salt, other one may be just like the dilute solution of acid, or it may be a base. So the concentration, the nature of that electrolyte, what are the ions, whether it is a simple ion or it is a compound ion or it is a complex ion, all these properties matter. And temperature. As you know, the temperature plays very important role in electrical conductance. Why? Because the electrical conductance depends upon the mobility of ions. So this mobility of ions is greatly influenced by temperature. So if you increase the temperature, the mobility of ions, the way in which ions are moving, so ions will move faster at a higher temperature. If you decrease the temperature, their mobility is decreased. Therefore, this temperature also affects the over voltage, and the current density that is supplied plays very important role. So electrode surface, nature of the electrolyte, temperature and current density are the factors which affects the over voltage. Now let us see why the actual over voltage exists. Now let us consider the electrolysis of water using platinum electrode. Imagine a beaker once again containing water and two electrodes made of platinum, and it is connected to the negative terminal and positive terminal of the battery. So direct current, and as a result a decomposition of the electrolyte takes place, that we call it as electrolysis. Now consider water. It contains H2O molecules. It undergoes self-ionization to give H plus and OH minus ions. Now here decomposition potential plays very important role. So H plus has one decomposition potential, electrode potential, then oxygen has a different reduction potential. The one with higher reduction potential, it undergoes reduction. So with the lower oxidation potential undergoes oxidation. Lower reduction potential undergoes oxidation, and higher reduction potential undergoes reduction. Now, why there is 0.45 voltage difference in the case of electrolysis water? So there is over voltage. So it is supposed to be 1.7. That is, of course, that is the actual potential 1.68 volt. That is the actual one, practical one. It is more than the theoretical value. Why it is slow? Why it is so? That we can explain by these reactions. So let us say H plus ion receiving electron E minus to give H. So atomic form of hydrogen is formed from H plus ion. Of course, this is reduction reaction. See, this reduction is very fast. H plus electron to give H. It is very fast reaction. Now let us come to the second reaction. The second step, the two hydrogen atoms reacts to give hydrogen gas. Now this reaction is slower. Why it is slow? Because it involves the reaction between two atoms. Now here the reaction between the H plus ion and the electron. So this reaction is faster and this reaction is slower. So here we have two-step reaction state first and second. The step second is being slow, consumes more energy, and it accounts for overvoltage. So whenever we have the reactions which involves many steps and it involves the evolution of gas at the electrode surface, at least one is rather a slow process and it requires more energy. So this is the reason for why liberation of hydrogen gas and oxygen gas while water is subjected to electrolysis takes more energy in the form of voltage compared to the theoretical voltage. Electrolysis of water is supposed to be at 1.23 volt, but this is not happening at this particular potential. This potential is not sufficient in the presence of platinum electrodes. We have to give additional 0.45 volt in order to bring about the decomposition, the electrolysis process. 1.7, exactly 1.68 volt is required for the decomposition. Now this higher voltage, what we call it as overvoltage, it is because of the multi-step reaction in the case of hydrogen. The first one is H plus electron to give H, it is faster, and the second step is slower. We have many reactions, decomposition processes where we have the first step and the second step and sometimes the third step. Now here we have the two steps. The first step is faster and second step is slower. Of course, if the process or decomposition takes place in one step, then the theoretical and practical voltage difference is less. Of course, that difference becomes less or it depends upon these factors: electrode surface, nature of the electrolyte, temperature, and current density. Dear students, we are discussing about factors governing electroplating at this moment. We have seen what is decomposition potential and overvoltage. Now let us see what is this polarization means. Now polarization, these are the factors influencing the electroplating technique. Now the potential to be applied for electrolysis is higher than the reversible EMF of the cell. The cell that requires excess voltage than the theoretical is said to have polarized. So whenever we see over voltage, then we say the cell is polarized. See, that the excess voltage is called polarization voltage. So over voltage that is required, polarization voltage, and the phenomenon we call it as polarization. Now this polarization voltage or the phenomenon of polarization may be because of the concentration polarization and over voltage polarization. See, when we are subjecting electrolysis, we have the electrolytic solution. Possible at some instant, ions may be greatly deposited on the surface of two electrodes. As a result, because of the larger concentration of ions at the surface of electrodes, the actual decomposition or electroplating technique is greatly influenced. Maybe the rate of the electrolysis or deposition becomes slower because of this accumulation of ions on the surface. So as a result, it leads to overvoltage or polarization voltage. So this polarization voltage, because of uneven movement of ions on the surface, is called concentration polarization. Sometimes this concentration polarization, because of the lesser agitation of the medium, or it may be the mobility, directly depends upon the mobility of ions and the type of electrolyte and the concentration, so on. It's also because of the over voltage, what we call it as over voltage polarization. Dear students, polarization and otherwise, it's a process in which there is the variation of electrode potential due to the inadequate supply of ions from the bulk of the solution to the surface of electrode. So there is a change in the value of electrode potential. However, the equilibrium is re-established as the metal ions from the bulk of the solution diffuse towards the electrode due to the existence of a concentration gradient between the bulk of the solution and around the electrode surface. The factors affecting the polarization is size and shape and composition of the electrode, electrolyte concentration and its conductivity. Once again, temperature plays very important role. Products formed at the electrode, rate of stirring of the electrolyte, larger electrode surface and highly conducting solutions at low concentrations decrease the polarization effects. Dear students, this is what we wanted to discuss under this part 1 about the metal finishing. Mainly we have included what is electroplating and how the electroplating technique is carried out, and what are the two important techniques of metal finishing, electroplating and electroless plating. Then we are discussing about electroplating technique and what are the requirements and factors affecting the electroplating technique. In the next part 2, let us discuss the electroplating and electroless plating of some metals by taking examples. Now here you can watch this video many times and you please understand the concepts and note down if it is required or necessary. You can draw the diagrams, then prepare your own notes if it is required, and maybe tomorrow I will upload one more assignment related to this topic. I kindly request all of you to watch this video lecture, and I request once again all of you to submit the assignments in time. So hope students you are all not worried much because of the COVID-19 home quarantine. Be safe at home and do not panic at any time, and take enough fluid in the form of water and take a rest. And I request all the students to meditate and for a few minutes, maybe for 5 to 10 minutes, and you can go through all the video lectures which has been uploaded from different subject teachers, and please, they are all here to guide you students, and you respond well and you go to the Google Classroom and all the assignments and video lecture which has been uploaded. Please go through and you talk to your parents, talk to your brothers, and if you have got any queries you can text message to your teachers. You can text message me too, and you can ask any sort of doubt, you can clarify, and don't be under any stress because you are at home. No need to bother at all. So we have been enjoying this video online session from different teachers, and I wish you all the best. Be safe or be at home. Thank you, students.